What's the percent composition of cobalt and tellurium in cobalt telluride? Well, you've come to the right place. First, we've got to find the mass. Let's use this table to help us out. Bam. So the first thing is we have to write down the particular elements that we see in the compound. So we have cobalt and we have tellurium. Next is to then identify the number of atoms of each, and that's where the subscripts come into play. So at the bottom of cobalt, there's an invisible 1, so there's 1 cobalt, and the same thing for tellurium, 1. Then we're going to take those numbers of atoms and multiply it by the mass of each particular element, and that's found on the periodic table. So let's take a look. Here's the mass of cobalt, here's the mass of tellurium, and those masses basically are in the units of gram per mole if you're calculating molar mass, or AMU if you're calculating molecular mass. The magnitudes of the numbers, though, are the same. All right, so let's write them down. So we got 58.93 units of mass for cobalt, and tellurium was 127.6. Then to find the total mass of each particular element, we're just going to take the mass of that element and multiply by the number of atoms inside of that compound. So that was a total mass of 58.93 for cobalt. For tellurium, it was 127.60, right? That math is pretty straightforward. And then adding this column together, we'll find now the total mass of the entire compound, right? So when we do that, we come up with a total of about 186.53. So consider that this was the first step to finding the percent compositions of each element. We first had to find the total mass, right? So now what I'm going to do is add a new column to this table, and the rest of this is going to be really simple. Bam. So to find the mass percent of, let's say, cobalt, what we have to do is we have to take the total mass of that element, 58.93. Don't worry about the units here. You can use grams per mole or AMU. It really doesn't matter. The magnitude is what is important. And then divide that by the total mass of 186.53. And then multiply by 100, hence why we had to find the total mass first. And when we do that division, this comes out to a percentage of roughly about 31.59%. Now to find then the percent of tellurium, you can actually just take this value here and subtract it from 100. But I would rather calculate it using the total mass, make sure the percentages work out correctly. Maybe I made a mistake here, and that would then cause me to compound my mistake. All right. So this would be 127.60 divided then by the total mass of 186.53. Simply multiply that by 100. And for tellurium now, we have a percentage here of about 68.41. Okay, and when you added, or if you were to add these percent, what kind of a number is that? So weird. I don't even know. It looks like an F. Oh, it looks like an F. That doesn't even look like an 8, right? That looks like an F. 6F.41. So when you add these percentages together, it comes out to 100. So I'm pretty sure we're good. Thanks for tuning in. That's how you find the percent compositions of those particular elements. Thanks for tuning in. I think I said that already. I don't really know. I didn't get a lot of sleep last night, as you can tell. See you in the next video. Hopefully I make it to it.